there is no intonation, it's very flat. Okay, and this is the reason that for us, other languages are difficult, English in particular, where you have intonation is very important.
But they are also really careful about using foreign language, I guess, right? Do you have special policy for that?
Sorry?
Not using foreign language, using just French?
In France?
Yeah.
We try to learn English.
I mean, in France, do you? I think.
No, we start now. We start learning English very early now, and I think the new generation is somewhat good in English because of Netflix, all the series.
Yeah, because in the cinema it's dubbed.
Yes, most of the young people look the series with original version with subtitles. Then you use English subtitles. So no, I think the new generation in France, the young will not be like me. They will better than me.
I can understand. Yeah, it's true. Sometimes when you meet people on the street, you ask in English and they answer you in French. And if you don't understand, they answer you in French slowly and louder.
Yeah, louder. Why?
I mean.
Good.
He works directly. It's a bit embarrassing. What's good linking?
They have a name of the places. Or the signs. Once I face that much language. Yeah.
Here's the detail. There's a journalist who will back as a journalist and he's ready to take the court.
No, thank you.
Just have to do half of it.
No, we can start.
But then like
Is it possible to take photos? Is it okay to take photos?
Sure.
Thank you.
I will tell you when all the secret stuff goes.
Yeah, but let me know it. Yeah.
I don't want you to do extra work with tech support.
Because for example, this morning, the meteor was streamed just like, yes,
I put you in contact with him. That's good. I'm sorry for that, but I thought it would be so. I got 2 coffees. Thank you very much. So now we're almost all the way from we can close the door there. So, welcome, Professor Bill Signer. This is the second in a sequence of 4 guest lectures on people-computer interaction, and they will talk about cross-media information spaces and architecture. So, Bill Signer works at the Final University in Brussels, where he's been for about 10 years' time now. Yeah, and it is PhD. And he's leading the group called Web and Information Systems Engineering, WISE. And he got his PhD from ETH Zurich, and where he also was having an interactive paper lab for 4 years there before he moved to Belgium. And yeah, so I'll give the word to Bill. Welcome. Thanks for having me here.
Yeah, so the title is Cross-Media Information Spaces and Architectures, and that's actually a lot of the work we're doing, or most of our work is around that topic. So what I decided to do today is to take some more recent projects and show you a few examples of things that are going on at the moment in the lab. But maybe first to give you a kind of motivation, what we mean by cross-media information spaces. So this is typically information we have today. So of course we have the traditional information on our desktop computer. Most of you nowadays use their mobile phone, so some of the information sits on your mobile. But we also deal with traditional paper documents. We have already seen earlier today, of course, we have blended reality. So interactive tabletops, ebooks. So there are tons of devices and also still more traditional type of media that we use to deal with our information. By cross-media, we mean, okay, how can we now deal with this often fragmentation of information? Because actually, you might have experienced that some information is on your phone, but you don't have it synchronized with your desktop computer. So information is only sitting on some of the devices. That's just in digital space, but then of course it gets even more difficult if you cross the boundary from digital to physical. So if you print out a document, you do some annotations on the document, how do you get that synchronized? Because normally you're working in two different worlds. So that's actually where our interest is then to work on this glue between all these devices and the information sitting on these devices. So I would say this is, as we heard this morning, a lot of it is technology driven, but we are more interested in the glue here. And as you will see, this also means a lot of information infrastructures to then drive these different interactions with these devices. Now, there are three main things we are interested in. The first one is, of course, how can we design our information in a way that it can easily flow between these devices. And now that goes beyond, I mean, what you see today is you might have your PDF document sitting on your desktop computer, and now you have a tabletop. So you move it to the tabletop, but actually the document is still the very same PDF document that you have on your tabletop. What we are interested in to rethink document formats, and to think like, should maybe the information or our document also be able to adapt to the device? Because, for example, if you have your text document or your PDF on your desktop, and you move it to your tabletop, maybe you want to have more kind of a graph-like visualization on the tabletop, where you have the different chapters, the pictures, and so on. So we are really interested in going beyond the traditional document formats here, and maybe also have, I will talk about that later, that this can even be context dependent on the user and so on. So document can change its structure depending on who is interacting with the document. Then the second important aspect is that we keep these things somehow connected. I mean, a good example is the handouts I have here. So these are just some printouts on paper, but there is somehow still a link now from this printout to the digital version of PowerPoint on my computer. And that's, of course, just one example, but in general, we are interested in if your information is then spread across these devices, can we somehow have a kind of like on the web, where we have hyperlinks between these different resources, so that you can easily move between them. And the third one has to do more with the user interface side. So of course, if you have now all these devices, often you don't use them in an isolated way. I mean, if you have a tabletop, you might bring your mobile phone, you maybe put it on the tabletop. You might bring some paper documents, you have them on the tabletop. So basically what you want to have is maybe also kind of a distributed user interface, where you can use some interface components on these different devices. So you have some functionality available only on your mobile, maybe it's more private controls. You might have to paper documents and so on. These are the three main components driving our research. So if I sum it up what I just said, it's about the fragmentation of information across different applications. I will also come back to that maybe again. So even if you're on a single system, like your desktop computer, often your information is still isolated or controlled by the application itself. So our goal is also to open that up, that different applications can better work across the information, different devices, and then of course digital and physical information environment. So that's also been my background. I did more than 10 years of research on this paper digital divide. So how can you integrate paper, physical space with the digital space? These are the three main things I just mentioned, and that I will also show you some examples today. So the linking, as I said, how can we link between the different media types? Then some new forms of more flexible document representations. I will show you at least one example in more detail about MindXpres, where we create a complete new presentation software, where a lot of that is also about having more flexible document formats. And then the cross-media user interface aspect, where you basically also want to give the user more freedom that they can build their own modular user interfaces across different devices. Now, in terms of the research we are doing, it's a bit similar to what Olivier mentioned this morning. I would say it's also very data-driven or data-centric. So I'm not an HCI person from my origin. I'm more a database person, and a lot of our research is first thinking about the representation of information, rich representations, and then we see how this can drive new interactions with the information. So you see we're working at the intersection of really more classical information systems or information management, and that's normally where we put a lot of effort in. And then, of course, once we have these representations, we see what can we do with it. So one is more on the information visualization and navigation side, and then, of course, also human information interaction. And what you see here around are just different projects we did in these different areas, and today I will focus just on a few of them, the blue ones. So I will just briefly, because that's a bit at the core of everything, introduce the resource-selector-link hypermedia metamodel. So this is really in the core, the system that allows us to link these different pieces of information, but also to build richer document formats. Then I will show you an example how we use that in personal information management, so PimVis. And here the focus was again not just Pim only in digital space, but to cross the boundary, because also in your personal information management, of course, a lot of your information is maybe digitally available, but still, I'm pretty sure most of you still also read physical papers or have information in physical space. So again, how can we close the gap there? Then I will give another example of this new presentation software, MindXpres, together with some rich, we call it plugins, media plugins, for example, for source code visualization. So I will show you how this is a platform that enables us to have rich media integrated in our presentations. Because what we have today is, mainly maybe videos and text, but I will show that we could do much more in a much richer way, and that might change how we give presentations in the future. And then, hopefully there will still be time, I will talk about some very recent work, which is about dynamic data physicalization. So it's really the idea that we cannot only visualize our data, but we are now trying to see how can we use physical properties to represent multidimensional data. So that means you could have, of course, a classical three-dimensional printout, for example, with a 3D printer, but then we would like to use things like temperature and other physical properties to represent other dimensions. So there to see how can we build interfaces that similar to what we have seen this morning with the huge wall. The idea would also be of large data sets, maybe a number of data scientists sitting together and discussing a data set, but instead of only seeing it visually, they can also really touch it and feel some of the features of the environment. So just to give you a kind of an idea, I mean, I could talk just 2 hours about that, but it's just that you know the basic principle. And of course, you can always go to my website and find then all the papers describing these things. But the RSL metamodel is really what drives, or what is in the core of a lot of our research to then represent the data. Here is a very simplified model with just the basic concepts in there. And this is actually the resource, the selector, and the link. So that's also RSL stands for 3 main ingredients. And the idea is now that on the upper part here, this is a very general hypermedia metamodel where you can link information together. So as you can see, links, selectors, and resources are entities. So this is like superclass or supertype. And then a link can have any number of sources and any number of targets. So I would say it's a very general hypermedia model that goes beyond what most hypertext or hypermedia model offer you, because you can have multiple sources and multiple targets. For example, if you think about the web, that's normally not possible there because you have one link anchor and normally you link to one target. So there is normally a one-to-one relationship. In our system, you can have many sources and many targets. And what are then these sources or targets? They're entities. So that means that the source and the target can be a link, a selector, or a resource. So that's also quite general. So you could, for example, have a link that has as an anchor another link. That could be, for example, some metadata you want to attach to. Resource is then always for a media type like the basic unit. So that could be a movie, it could be a web page, or it can be a piece of paper. And that means if I can now link, I can now have a link with a resource as a source and something else as a target. So that means I could, for example, link a piece of paper to a movie, or I could link a movie to something else. Now, often you don't want to link an entire resource, but you want to link a part of a resource. And that's why we have the third abstract concept, which is a selector. So a selector allows you to address parts of a resource. For example, here I can define different shapes. And then if I click on a button, it basically triggers that link and goes to a specific slide. Now this is all, there is no media type at all involved at this upper part. So this is a very generic hypertext or hyperlink model. And what you do then is you write plugins for different media types. So for example, I mean, originally, this was mainly used for the interactive paper, where you wanted to link paper to some other information. So what you can do now is you can write a plugin, and the only thing you have to do in your plugin is you have to define what is a resource for this media type and what is a selector. So for the interactive paper, you could say it's an entire page is my resource, and arbitrary shapes you define on the page are then actually the selectors that you can use. Or here you can see we did the same for other media types. For example, we have one for the web, where you say then I have my HTML documents as a resource, and my selector is actually an X-pointer expression to address parts of the resource. And then you can see we have a plugin here, and it allows you, for example, here I selected the link, but you can see now that this was a multi-targeted link. So it has not only a single target, it has multiple targets. So in this case, it would show you a pop-up, and it would allow you to select the target you really want to navigate. Or here it was for movies, where the resource was a movie. The selector can be different things. So here you can say it's just a time span, and you could say from here till here in the movie, I define a link. Or what you see here, we have a combination of the selector. So we said time span in combination with position. And that means you can now see here the shapes that are active. So that means over time you can follow certain objects in the movie. And you can actually track them and always have a link anchor on one of the objects, and you can click on it. Now, as I said, this is really in a nutshell the thing we are using. What later becomes important, I mean, now it was just linking between resources. Later I will also show you that actually two different types of links. So what I talked about so far, we call them navigational links. That's to navigate between pieces of information. But then we have also structural links. And we use these very same links to actually model document structure. So you could, for example, say a resource can now be a chapter, and then I have different sections in my chapter. And I would also use these links to say a chapter consists of these sections, and then the sections consist of these paragraphs and these images and so on. So with that, I can also model an entire document structure by just using these links, actually. Now, the first example I wanted to give you was about personal information management. So this is a typical thing you might see in today's offices, that people, of course, they use manage their digital information. So just on the desktop, you might have other ways how you organize somehow your digital information. But also, a lot of people still organize information in physical space. So this is actually an office back at ETH of one of the information systems professors there. It looks very, I would say messy, but actually this professor, he knew exactly where the documents are. So if you were asking for some information, he knew exactly in which pile more or less where the document is. So it seems this person has a way to organize the information in that space. Now, the work we did here is then, as I said earlier, the idea was to combine it. So we want to do, of course, the classical PIM task by keeping, organizing, and very importantly, refinding your information after some time. And the important thing here, as I said, is that we want to do that in digital and physical space, so that we can somehow combine these two aspects. Now, of course, we did a number of studies, also based ourselves on a lot of the existing work that is there in the PIM community about filing, piling, and other ways people use to manage the information. And then basically we slightly extended the RSL hypermedia metamodel that I've shown you before to, or not extend, but we used it to metamodel actually the OC2 PIM model. So this is then a new model that is more specialized for the personal information management. And also important, so what you can do then, I will show you a slide, on the next slide you will see the system. You can now define explicit links, so that means a user can really say, I want to define some associations between pieces of information or pieces of documents. But the problem there is, yeah, it's always the time it takes to do that. I mean, we all know you get a lot of information, and if you want to nicely organize everything, you spend all your time in just organizing your information, so we don't have that time. And that's why the system can, of course, also track how you interact with documents and then implicitly create some of these associations. For example, it could know that you are now working in the context of a specific project, and then if you use certain documents at that time, it knows, of course, that these documents somehow belong to the same context of a project. And if you later on want to retrieve information and you are again selecting this project, it can show you information that is related to that project. So that's what I mean by these implicit associations, where the system is just creating some of the metadata automatically for you. So here you see then some of the artifacts. So we had our own multi-touch table that we developed, and you see now PimVis running on the table with a kind of a graph visualization of the document space. I have here a single picture that shows it a bit better. So you can see we have different documents. There are these links or associations between documents. They, for example, also have different color and different thickness. So that tells you something about how related are these documents. So we try to visualize that in the graph structure. Also important, you have, for example, a timeline. So you can also go over your document space over time, because of course these things change over time, and we want to go back in time and see what happened yesterday and so on, so you're free on that. And you can then actually also select some other menus here on the side. You can also zoom in and zoom out. The problem is, of course, this is a tiny example, but if you think now that all your documents are managed like that, you get a huge graph. And of course, you will completely lose the overview. It's a bit like this in the talk this morning. You can either go close and see the details, or you want to go back. So we had a bit the same here, where I didn't have the slide in the presentation. Here. So you could zoom out, and then you see really just an overview telling you in colors what type of project is it, and then you can zoom in into the different clouds. So then you're back actually here, but also here you can further zoom into the thing and focus on a single document. So this is then like the focused document view, where you see a single document still with its relations to other documents. Now this was on the table. And you see here a user interacting with the system. But as I said, the idea was then to bridge the gap between physical and digital. So for example, what you could now do, you could put actually a physical document directly on the tabletop, and we had a camera that could actually then identify which document is it. And it would then just do the same layout around your physical document. So basically what you do is you just put your physical document there, and it shows you some digital links to the other related documents. So actually not a lot of effort for the user to access the related physical documents. Or here you see, it's not very visible, this is a filing cabinet that we did, and you see all these LEDs that we have here on each folder, and it was actually tracking your physical documents. So that means if you're now here on the table, you can right-click on a document and say, where is the document? And then the LEDs will actually light up. We also have here on the folders some LEDs. Now, one is you can track just a single document, but you can also, again, if you're, for example, in the context of a project, multiple of these LEDs might light up. And it just shows you, by the way, for this project, there's still some physical documents in these folders, and you might want to also have a look at those again. Or here it was a paper tray where we used some distance measure here to automatically know in which tray do you put it, and then some LEDs to again show you a physical document is actually there in your tray. So it was all about making this transition much easier from the physical to the digital. And as you might have experienced, sometimes you had something printed out 2 years ago. You have some important notes that you made on it, but you cannot find it anymore in your office. So the idea here would be that if we can track the documents, we might get some feedback. Where is this physical document sitting in our office, actually? Yes, so that was the PIM side. Now another longer project that we had, so that was one of my PhDs who recently finished this work, was all about, as I said, we often think about like what's wrong with document formats in general, or here you're thinking what's wrong with slideware. And so slideware, that's the presentation software used today, like PowerPoint, Keynote, and so on, where we just have this way of showing slide after slide. So if you think about it, I think a lot of the limitations that we have today come from the fact that actually the software that we use today is still very much a simulation of physical slides. So most people don't know, but actually the first version of PowerPoint was mainly developed for this device here, which was called a slide projector. And that's from where we have the concept of a slide. Because actually, you would print then your slides on the small 35mm things we put in here. Also things like linear navigation that we have today in presentation tools comes very much from here, because actually in these devices you could just go from one slide to the next slide, but it would not show them in random order. If you had a very sophisticated slide projector, you could also go backwards. But that was already a special feature, and most of the time it would somehow jam and it would not really go backwards. So that's where we think like maybe, okay, the basic principles we use in our presentation software are based on these devices we have, but today we have more freedom with the projectors and so on, so maybe we should see, is it still the best way we use presentation software today? And as I said, what are some of the issues? Limited space. Of course, because on a slide, there was a limited amount of information you could put on it. You might, I'm sure most of you have seen Prezi and these kind of solutions, where the idea is that you no longer limit the space, but you say I have an unlimited canvas, and I can have a zoomable user interface and put my information on a single slide and zoom in and zoom out. And this is also something we support in our software, that if you want, there is unlimited space, and you're no longer bound by the size of the slide. The linear navigation, I already mentioned that, and this is, I think this is a very important thing that still limits us a lot in presentations. That's also something I learned with PaperPoint that I'm using here, so I'm using that now for more or less, I think 14 years in every single presentation, every single lecture I give. So I always use this tool, and it really gives you a lot of flexibility, because I can really jump around quite quickly from one slide to the other. Often I put then the slides that were presented here. So if I just want to go back to something I've shown earlier, I have my overview here and I can easily do that. This is normally not so easy in a presentation. Either you have to think about it before, or you have to know your slides and type in the slide number, or you have to go through all your slides. This is getting annoying for the audience here. Normally you don't see any slide numbers on my slides. So that also means you are even not aware. So for example, if I give conference talks, I always have more slides than I want to show. And I'm adapting the presentation on the fly. And you will not see it, because I mean, the slide numbers are not there. It's just slide off the slide. So you have no clue that I'm adapting the presentation while I'm giving the presentation. So this is definitely something where we can do better. Monolithic documents. This is also, I think, a problem of existing presentation tools. That actually, a presentation is a container, and it contains your slides, and that's it. So what now if you have a question, and I know I have a slide in another presentation, it's very difficult for me to bring up that slide, because I would have to leave the program, find the other presentation, bring it up, and so on. So we, again, by having this data-centric approach, for us, it's not about a single presentation, but we see it more like a database with all your information. And the particular presentation is just a view on part of that information. But that also means I no longer have the concept of a single presentation. That means at any point in time, I can go to any information that is available in my database. And think about a class where you have students, questions come up. I mean, you can very easily then go to content that was maybe not planned in your presentation, but that you have somehow available somewhere. A bit related to that, difficult to reuse content. I will also show you some examples of that. I'm pretty sure those of you who give lectures, what do you do normally at the beginning of the semester? You copy-paste the slides from the previous year, and then you start from that and do some updates to the slides and so on. But actually 80% of the content is a replication of content you had in the previous year. So that means over time you have many, many replicated slides. Here the idea in MindXpres is that you don't have that anymore. So we use transclusion, which is a concept from the hypertext community from a long time ago, where you say instead of copy-pasting content, you're just putting a reference to the content. You're actually referring, having such a structural reference to pieces of information, and by that you also add it to your presentation. But that means you no longer replicate information, and if a slide is used in many presentations and you do an update on that slide, it's of course automatically in all your presentations, and not as it is today that you update information in the presentation, but you forgot to copy-paste it to the other presentation. And then another one is the rich media types. Of course, for the slide projectors, there was not so much rich media type that we could use there. And I will show you an example in a moment that it can sometimes make sense to have better support for these rich media types. So let's see, I think this is just a more general thing I still have. So here you see actually a MindXpres presentation. It looks, so this is the overview, but as I will show you in a moment, it's also completely up to you. So everything is done via plugins in MindXpres, and this is just one possible view that you can have over all the slides in your presentation, where we somehow group them a bit, and then you can go through different slides. But if you tomorrow want to have another visualization, that's relatively easy to do that in MindXpres. So we see MindXpres as a platform also for other researchers who want to try out new ways of doing presentations, and they don't have to start from scratch, but they can actually just write their plugins for MindXpres. Now again, of course, it uses RSL for the navigation, but as I will show you, also then for the structure of the presentation. So as I said before, a presentation has then a number of slides, and slides have contents, and that's all modeled by these structural links. Very clear separation of content and structure, which also makes it easier then to reuse content. Now reusing, it's normally relatively easy to reuse a single slide, but what if you only want to reuse parts of the slide? It's becoming more complicated. And what if you used another visualization in one presentation? It's getting harder to reuse actually content in one presentation. That's why we clearly separate that, and we say the user should really focus on the content. So for those of you who ever use LaTeX to write a paper, it's a bit the same idea, that you say the user focuses on the content, and MindXpres does then more or less all the visualization for the user, so that you don't waste all your time for the visualization. The tool itself, it's completely based on HTML5, CSS3, and JavaScript, which is pretty cool because it means it runs on any device that has a browser, so you can have it on your mobile phone or on your tablet or whatever. It's a content-based approach, that's what I just mentioned. You focus on the content and the system does the rest. We have cross-media content reuse. I will show you some examples of that. And then also the non-linear navigation. So that means you can actually define, for example, a predefined path, but at any point you can, of course, zoom out and go to any slide and relatively easily jump around in your presentation. We have the linking, associative linking that is supported, and it can again be explicit by the user or implicit. So what do I mean by implicit? What you can do now, we didn't implement that yet, but it would be easily possible that we check all the content on your slide, and let's say you have now somewhere, what did we, I don't know, a concept of keyword XML. I find that. The system then can search in your database, and it knows there is actually a slide that really gives the definition of XML. And what it can do then is add a link implicitly to that keyword. And you might even not see it on your slide, but if you hover over the keyword XML, there will be a link to that other piece of content. And of course, that means that's a very flexible way to deviate from your standard linear presentation if there should be a question by a student. So if he says, yeah, but what does XML mean? You can just hover over it, click on it, and you bring the content up that you actually want to show. And then the rich media type. So I'll show you now 2 examples. So this is maybe a bit too technical. So this is just giving you an idea how things are represented internally. So you see here a presentation, and the brown arrows are actually structural links. So you say you have here a presentation which has 2 sections, as we have seen it before, the containers, and the containers have some slides in there, so it's all modeled over these links. And the green ones are then the navigation. So here the user defined in which way will they navigate through the presentation. But more importantly, you see, for example, here now another presentation that has also some slides. And you see, for example, that this slide here from this presentation is also used in this other presentation by having such a structural link to this slide. So I'm no longer copy-pasting, but I'm just referring to a slide from another presentation from this presentation. So this is this transclusion that I mentioned earlier, which is really powerful. So here you see one of the rich media plugins, which is for source code. So I'm pretty sure quite a few of you have to show source code to students sometimes in their lectures. How do you normally do it if you have to prepare slides? I mean, I'm pretty sure you have to do, okay, you're not lecturing that, but you show somebody or an exercise sessions, I'm sure. So you copy paste your source code, right? You somehow maybe try to do some syntax highlighting on the slide that it's a bit more readable and so on. So you can quite easily spend quite a bit of time to have some simple source code on your slide. And it might also be, again, what I said earlier, this restriction from the slide might also make it necessary that you copy-paste your code over multiple slides, because you might not have enough space on the single slide. Now, with our plugin, it knows then about source code. So basically what you do is you just put the reference to your actual source code, and all the rest is done by the plugin. So what will it do? It will first detect in which programming language is your source code. It will then automatically do the syntax highlighting for you. So basically what you see here is a MindXpres slide that has been generated by just putting a reference to the source code. So this is then the source code that you see. You see there is also a scroll bar on your slide because there was not enough space. And then in this case, we first had a version that could only do that. But here what it also does, it actually throws your source code into a special program that will actually execute it and annotate your source code. And that means later on your slide, you can now execute your source code and go through it. And you get this visualization on the right-hand side, also all done by MindXpres. So where it will show you the values of the variables, it shows you the call stack at the point where you are in the code. So you can step by step trace through your code. And this is, of course, quite a help for the student to build up their mental model about the codes that is shown to them on the left. This is, of course, also again flexible. It's again a plugin, because this might not always be the best visualization. Imagine you want to have some sorting algorithms, then it's maybe better to show an array where you can see how the elements are moved over the array. So then the only thing you have to do, you have to write here a new visualization. But the point is, from now on, once I have written this plugin, it's zero effort for me to use it. I only have to refer to my code, and that's it. All the rest is actually done by MindXpres. Or another quite powerful one for rich media is for interactive data visualization. So how do you normally show this type of data in your presentation? Yeah, maybe you are in Excel, you have your data, and then you create all the graphics, you export them, you put them in your PowerPoint presentation. What's the problem? It's very static. I mean, it's basically just an image that you put in your presentation. Here, actually, all you see is based on the very same data set. So what we do is, again, like with the source code, we just put the reference to the raw data set, and all what you see here is done in MindXpres itself by the plugin. So that means, actually, I have a rich data set about the taxes in Europe, and I start by only showing it for Belgium, but there's always the very same data set. And then I start to go through it, and I adapt it, and I tell my story, and I'm more flexible. You will see that in a moment I show a quick video, because I can now change it on the fly. While giving my presentation, if there is a question in the audience, I can interactively change that. You will see there is a menu, and I can say I want to have no longer a pie chart visualization, but something else. and I work with my data during the presentation. Of course, that's something you normally don't have if you're static images in PowerPoint. And another, there are many more features, but one thing we also have is the kind of mirroring. So if I'm, for example, giving the presentation, any device can connect to a hub, and then they can actually see a mirrored presentation on their device. And I can even give also control to some of these clients. So that would mean if somebody has a question, they can directly control the presentation. For example, go into the specific slides and also navigate through the presentation. So here I don't have the live demo here, or I could maybe for tomorrow I could also show that, but I have just a very short video where you see some of the things in action. Start. Let's see. Oops. Let's go back. Where are we? Oh yeah, so here you see the zoom in, zoom out in the presentation. And this is, for example, the plugin I just mentioned, where we can now go through it. So this is like a predefined path, but then at some point you will see that the user starts to also dynamically change things. Let's see, I will pause it. So this is still just going over the data set, but it's all pre-authored. And now you see that he will start to here. So you see now down here you have also some menus that you can use, and then you can just change things on the fly. So this is now dynamically in the presentation itself. So actually now you see that you can change the visualization on the fly. So it's no longer just a static image. Or this is the source code one that I mentioned, where you can scroll through the code. It was the first version, and this is the more advanced one that I showed on the slide, where we can now step through the code, and we see actually the update on the right-hand side about the variables in the call stack while going through the code. Yeah, this is less, that's what I said earlier, so these are just some slides we have, it's all data-driven. This is an example now of a slide, just to give you, that's a bit one of the, I mean, we have now a very powerful tool, but the big limitation at the moment is the authoring of the presentations. So, of course, my PhD student didn't focus on that, because building a nice visual authoring tool, that's a huge development effort, and it doesn't give you anything in terms of research. So at the moment, our presentations are defined in this XML format. And that's, of course, a killer if you want to give it to non-technical people, or even for some technical people, it might not be trivial to author it in XML. But of course, that's now the next step, what we will still need to make it something that everybody can really use, that we need a nice visual front end to do the authoring. But nevertheless, you see here, for example, that this is a slide with some bullet items. But then here, for example, this is again a good example of this transclusion, because it's not only reusing slides in other presentations, but often what you also, if you have, for example, a picture that you want to use in a presentation, what do you normally do? You copy paste it maybe in the folder where your presentation sits, and you might do some modifications of your picture, you might crop it a bit and so on. So that means also there, over time, you have many different versions of the same picture spread all in your file system. Here we don't do it. So you see, I use transclusion as I have an image. I point to the source where the original picture is. And then on this structural link, I can also define some properties. So here what I do is I do an on-the-fly cropping of the image. And that means only at presentation time, the system will get the image and do the operational transformations that I defined here. That can be cropping or changing a bit of the color and so on. But I mean, it makes it, again, you no longer have 10 different versions of your picture, you have one version, and you do then the transformations. I think I have only 5 minutes left, but I will move to the last. That was still the video, let me see, but I think there is not much. Yeah, what is also interesting is, so we, as I said, you can connect different devices like your tablet, phone, but also clickers and so on. Which then means, of course, that you can do things like these interactive polls, where the audience can just vote in real time, and you can show it again on the slide. Can be very handy for some lectures. That's basically it from the movie, I think. Discussions. So So that brings me to the last example I wanted to show. And before I go into the dynamic data physicalization, so this is a project we did some years ago called PimVis, which was all about the tangible user interface for a large arts database. So actually what we did, we took an open source collection of 30,000 pieces of artworks that exists and is freely available. And then we built that kind of tangible interface. So what you see is we have basically a screen here where you will get feedback, and all the rest of there is no keyboard and mouse or anything. So actually all these artifacts here, the paper tubes and everything, they have some RFID tags. And basically the idea is now that you can interact with these artifacts, and if you put them close to the RFID reader that is integrated here in this painter's palette, it drives the queries that you see here. For example, you have here different tubes. One says it's about Italian art or whatever, and if you take it and put it close here, it only shows you the pieces of artwork for that particular genre and so on. So it's really not mainly for finding a single piece of artwork, but actually for seeing collections of artworks, because you have then, for example, here also some physical controls, like a physical slider, where you can go over the different centuries. So actually you can then see Italian art, and by just using the physical slider, you see, of course, how it's spread over Europe, and then you can get some new insights based on the whole collection of artworks. We went further with that. One thing we did, we extended it, because this was quite simple in the sense that there was always one object, and it would drive the query. Then we said we should be able to have more complex queries where you can combine multiple objects together. But still, a problem here was the feedback. I mean, it's a very classical tangible interface, like in Ishi's tangible bits, where you say you have these physical tokens that are linked to some digital information. But it's not the other way around. So everything we get back, it's always just on the digital screen, actually. And we thought, I mean, it would be nice to maybe also have the physical objects representing some of the data. And that's where we come out to the more recent idea, where we want to use actually, we call it dynamic physical data, dynamic data visualization, where the idea is we go beyond just the visualization of your information, but we also use the physical properties of objects to give you some more information about the objects. So physical objects are no longer just used for input, as in the traditional, I mean, that's also not new. I mean, Ishi also has the concept of radical atoms, where they say we have, in the future, maybe programmable matter, where we can program materials, and then they can change some of their properties. Now, the problem with that is, and also Ishi says that we don't have the material today, but let's already think about some of the interactions that might be possible. And let's maybe simulate some of that material that might be here in the future. So what a lot of labs are doing, you might have seen that they have these 2.5D displays, where it's a tabletop, but now with pixels that can go up and down. So you start to have some shape-changing interfaces that you can use to simulate some of these things. So basically, they're trying to make the physical more dynamic. And what we are doing, or with one of our recent prototypes, we go exactly the other way around. So we said, let's start with the digital, and let's try to make the digital more physical. Now we started with holograms, so we used the Microsoft HoloLens, and of course with that we have a nice way to project your data, so you can project the data set. But what's the problem? As soon as you want to interact or touch it, there is just air. So there is, I mean, that the illusion is gone once you try to interact with your data, actually. And that's why we came up with the idea of TangHo, the tangible holograms. So actually you see here the user wearing a Microsoft HoloLens. You see then the data, and what we do now is we have these two arms, robotic arms. So that's a wearable system, actually. It looks very much here like as if you would use it for interaction, but it's also more for the feedback. So you have to imagine, I see now something as a hologram, so it could be just a simple sphere in front of me. And if I now move towards the sphere, the system is tracking my hand, and it will move one of these two balls to the point of intersection fast enough. So that means if I now want to touch it and my ball is already there, when I will touch it, I get some physical resistance at the point of intersection where the actual hologram is. And if you can do that fast enough, you can model any physical surface, because you could have a wall in front of you. And if the ball is always here, you get some feedback from these things. Now, we built an early prototype on Lego Mindstorms and using some 3D printing technology. Speed is, I mean, we couldn't do a decent evaluation so far because it's too slow. I mean, but I think conceptually it could work, but we need a lot more engineering, and it's a bit out of our comfort zone with the whole mechanical engineering and robotics, but we are trying to see maybe that we can have a bigger project where some partners can help us with that. The idea would also be that these spheres, of course, we could make them interchangeable, and then you can see on the spheres itself, you can give some additional feedback. So you could imagine that you can change the temperature on the sphere. Or you could have the idea of the 2.5D display on the sphere itself. So that means you could give some finer granularity feedback on the sphere itself. So I think we are the first ones here that have actually also a mobile solution, because there are some systems, they have a robotic arm sitting on a table and you can use it, for example, in VR to get feedback. But so far I haven't seen any mobile system. It also introduced a lot of new challenges, because the problem is it's mobile, but that also means you no longer have a reference point that is fixed. So because your body is, of course, moving, that means also here your point is moving and the calculation becomes very difficult. But actually, from what we have seen, yeah, there is definitely a potential in that. We will now not, as I said, we are not pushing tremendously on that, but more on the more general idea. Yeah, this is another example how you could use it, for example, here in car design, 2 users wearing it, and instead of having the large clay model, it's now just a tangible hologram. And it also means one of the users could go back to their office, they could have a smaller model there, work on that, and the 2 models could be synchronized. So you could really do some nice collaborative work on these holograms. Now, what we are really working on now is, in this direction, is the dynamic data visualization, and to see how can we use that. Again, like I said, we are very much interested in data, to have new forms of interacting with the data and not only visualizing the data, but give you also some physical feedback. And that can be interesting for multidimensional data. If you want to go beyond 3 dimensions, it becomes harder to just use visualization for that. And then we could start to use some of the physical properties, like the temperature or the softness of your material or whatever. But of course, for that, there is a lot of work still ahead of us. So we first have to better understand the entire design space, how the users map data to physicalizations. At the moment, there are hardly any design guidelines. Of course, there are some projects around, but there is not a common ground on that. So that's a bit like with what Bertin did for the information visualization. I think in the future, you might need something like that for the physicalization. Because, of course, for example, let's take the temperature. I mean, you can use it for maybe variables that have only a few different values, because we cannot easily distinguish different temperatures. So you could say I can use it for a variable where I know I have only 5 different values, and then you can use that. So you really have to come up with some guidelines here. How can you combine also different of these physicalizations, because not all might be combined. So that's what we try to do at the moment. We started with that, with this dynamic data physicalization framework. So it's to set up a conceptual framework as well as a software framework that will then again help the community to go further on this track. Actually, one thing is having a grammar. So that's related, of course, to the guidelines, and we define a new grammar, what are the possibilities that we can do. Also important, actually, it's my last slide. So you see, the idea would be you have your data set. Then the user specifies, for example, what they're interested in your data set. So it could be you have a 30-dimensional data set and they want to focus on certain aspects of the data, so they specify that. Then we use our grammar that has to be defined, and by that we know then what are actually the possible representations or physicalizations of our data. then the user can still assemble the thing because they might have some of their own preferences. Some users might say, I don't like temperature as feedback and so on, so they can actually customize it. And what we then create is a physical device independent output. So that's important. So this is then just telling you which physical modalities are used, but it's not bound to a specific device. So again, we want to abstract away from having a particular device, and then it depends on what hardware you have available. So that's what I mean here by the driver selection. So it could then be that you use TangHo that I showed before as the output device. But this is actually, how should I say, it doesn't have to be changed if tomorrow you have another output device. So the only thing you will have to do, you will have to write a new driver, and then you can use all the rest here in the whole framework and actually use it. And that's where I see that the community could profit, because not everybody has to always start from scratch. But if we together can develop such guidelines and the grammar, then we can, if we build new hardware, we only have to work with this part and not on all the rest, and we can use all the data sets that actually. And then, of course, in the end, you create your output, the physicalization, the user can interact, and this gives you the feedback loop back to the origin action. Sorry that I was 5 minutes over time. I don't have conclusions, I just leave that slide here, but I think if there is hopefully some time now for questions also. Sure.
The Q&A session here. Thank you very much. So let's see around the table. Are there questions? If there are. Yes.
Great talk. Thank you.
Thanks.
I have a question from a user perspective.
Mm-hmm.
Well, both are from a user perspective. The first one is from the student's perspective.
Mm-hmm.
The second one is from the presenter's perspective.
Mm-hmm.
So you showed a lot of very cool tools
mm-hmm.
that would sort of enhance and empower, basically, the different possibilities of making PowerPoint presentations more interactive and less linear and things like that. From a student perspective, I have some of my students students are very different, but some of them really need you to tell them in the beginning, look, this is going to last for 45 minutes, then we're going to have a break. Mm-hmm. This is the structure, this is what we're going to look at. There's 57 slides, so you kind of know when things are going to end. So how would such an amount of flexibility and links and diversions from the main story help the students in their learning?
It's a good. I think it's a very good question. Yeah, and I mean it's. Let me see how I can. So first of all, it doesn't mean that you will not have a very well-defined presentation how to give it, and that's also something I learned here. As I said, we had them, for example, once we did a visit to the US, and then I would just have 100 slides, and I would use those for all my presentations, so it was just a single presentation. But that doesn't mean that you don't have to be very clear on how you will show it, and that you just physically write it down. That would be the same for the lecture. I mean, the risk is that you are not prepared and you don't have your story. I think you need your story. So by that, you could still, students should be aware what's going to come. You have the flexibility that you can deviate, but you have to be careful with that, of course, because you still have to present all your material. And what I didn't mention, you of course record also the whole interaction or how the slides were given. So later you can put them online and the students can follow it also in this direction. Now, where the additional benefit for students might also come, that they can then, because it's all web-based, like with the source code, they can also replay that later at home. And they can again go through the source code. And so I think there is an additional benefit, or like the data set. I mean, I showed it then in one way in my lecture, but maybe the student wants to further experiment with the visualizations and change some of these things. So, but I agree, you have to be careful, because giving them also too much flexibility might also be a risk for some students, because they might get lost in that. And I would not say this is just great because it's I mean, you definitely need a well-defined story that you want to give. But then it empowers you, if necessary, to do certain things.
I guess you already answered my second question, which was if I were to use such a system, if I have planned this with my original plan, then I start to deviate, and students said, I always share my slides at the end of the talk. So you mentioned that you record the
that you can record it in the way we give it.
Do all these jumps.
What you can also do is, I didn't show that, I think there is also, I think I had a slide for it. Oh no, it was in the video actually. I think it was just when I stopped the video. Let's see whether it's still there. No. So also there, for example, students can also define questions while you're giving the lecture and even raise their questions. So that's also a nice way of feedback. That I, as a lecturer, can, for example, at the end of the lecture, take the top 3 questions or stuff like that. I mean, I'm not saying it's the best way to do it, but you can start to experiment with that. And of course, imagine students either have the printed handouts or they use their tablet. They can also share their own annotations with their colleagues. So that can also be that a few students work together and then they share their notes. They might not want to share it with everybody, but even then I could at least track on which slides was there a lot of interaction going on. And for me as a teacher, it might even give me some hotspots and say, on these slides, a lot of students annotate stuff or whatever. And that might give me a hint that maybe something is not clear on the slide. So I'm not saying this is, that's why I said MindXpres, I see it more as a platform that can then indeed be used for now further studies. Because I mean, I just showed the possibilities, but the idea would now be do small experiments with some of these aspects and try to see is it really good or bad to do it. But it makes it easier to do these experiments because you don't always have to start from scratch to build your tool lecture. But I'm not saying this is the way how it has to be. And I think it's also very different for different domains because this cannot only be used for students, you can also use it in companies. And I think they might have quite different needs, what they want. So you could easily write some other plugins that are done very good in business to present information there. Again, we see it as a platform that can actually support these kind of things.
Please here, yes.
Okay, yeah, thank you for a very interesting talk. I may have a little naive question. I'm just thinking, it seems it's a large data networking and the links. Who is building the links? Is it human or is it the machine?
It's
the system?
both. I think I mentioned it for the PIM, so you can have the implicit or explicit links. So indeed, it can be a bit of both. For example, for the presentation, normally the navigational links, you would somehow build them because that's a bit related to Andres' question. You will define how you go through the presentation. You might, even if it's not slide after slide, that's what you saw here. I would then say these green ones are the navigational links where you define a path how you want to go through your presentation.
So
that would be you as an author who define that somehow, where you say, this is my story and this is how I want to show them. But then, of course, a lot of the links can also be generated automatically, like in the PIM example, where I said the system can monitor what you're doing and try to derive some of these links. Or nowadays, where everything is about AI, you could have some AI components that can try to find some of these relationships between components. And then it could just use our system to basically store this metadata. So by just using these structural or navigational links. But it's, of course, not always that you have to manually author these links. Or if you have now the visual authoring tool, of course, it will not be about defining links. That's what I said for the presentation tool. So you will just do it visually, but behind the scene, it will create all these things. Because instead of having just a slide and nothing more, if you then move your stuff around, it will know, this is a slide container and has an image on it, and it will store it in this rich format behind the scene. And I didn't go into how should I say, for me it goes beyond than the presentation anyway, because now I told you we used RSL for the PIM, but we also use it here. So basically you have the very same representation in the backend. But that means also the boundary between what's now presentation content and what is other content is completely blurred. So our view, or we see it more like you have one database for all your content, and then if you do a presentation, it's again just a particular view on your content, but you no longer have to say, this is now presentation content or this is other content. So in the presentation, you can just refer to some of your content that is stored in this database anyways. So that's a bit the idea behind it, that we have one common representation of all the information actually.
So if I understood it correctly, so we as the presenter who is using this plugin system has to feed the data and has to feed
Yes, sure. I mean, that's, of course, also there you have possibilities because, I mean, there exist some metadata standards and also some online platforms where they have already generated content.
Yes, yes.
So you could, of course, also integrate those. You can do a plugin for this and we already worked with that. It's not, there is a lot of content out there in RDF annotation or whatever, and you can also integrate that. So you could then even profit from already existing content and you don't always have to author it. But yeah, in theory, you can do that's then still more or less the same as you would do it normally with your presentation. But if you want, you might profit from third-party content.
Yeah, thank you.
So one more question, and then we have to round off.
So, so my question is about this. What you said that when developing this tool of this slide set, it's not slides, that how to compose the presentation. So I understood that your next step is to like put somebody to develop the
From them,
yeah. And then what do you plan to do after that? Do you want to release it? Or?
Actually, we are at the moment looking also to commercialize the whole thing. So we really, it's a bit problematic because my student, he left actually, is now working in a company. He was the main person behind it. But we are still looking into possibilities to do a spin-off or commercialize some parts and really also make it available. Maybe not only for commercials, but as I said, it could also be seen as a research platform. If other researchers want to experiment with new forms of presentations, then this would also enable them to, yeah, it would be easier for them to set up their experiments and they don't have to implement everything from scratch. They could maybe just write 1 or 2 plugins, put some content in there and try it out with some users. But we definitely, hopefully, that would be the idea to make it available to other people. For the moment, it's not yet open, but I mean, if you're interested, you can always also contact me and we can see what is doable already now, maybe with some special agreement that you can have a version of it. I hope, yeah, I mean, it's a pity because I was even not using it yet for my own presentation today. So ideally, and it would be possible, I should really set one up for these presentations, but I also don't have it combined yet with PaperPoint, so I really have to integrate a bit everything because I don't want to lose the thing I have here, which is also very handy, but of course that we could also integrate into MindXpres so that we can also print it out and still drive these presentations. But yes, I mean, we see it. It was a long process, so this was more or less 6 years of work of the PhD student with many master thesis projects. So there were maybe about 15 master thesis students working on some of the plugins you have seen. And also from my side, a lot of work went into it. So I think it would be a pity if that would just stop at this point, because I mean, we didn't do a lot of studies or experiment now really. I mean, we have more like I can show you now the possibilities, but it's not that we really did now an evaluation of all that. A bit the same for the PIM, but there it's super difficult to do the evaluations. I think you will see tomorrow it was the same problem for our candidate, because you have to actually give it to people and they have to use it for half a year. How can you do that? I mean, for me, it's always very difficult to do the evaluation of some of these systems. So what we did with the PIM system, you give them an artificial set of documents and files, but that's never the same. I think ideally you should be able to roll out the system, but then you have to really, we are just a research lab. We don't have the manpower to build then something that is robust enough that they can really use it, and otherwise they mainly complain about some usability issues with your system and not about the features that are there. I think in your thesis I read some similar. So yeah, but I'm very positive that this will definitely become available in the future.
Okay, thank you very much. Unless now we take 15 minutes, we start 35. There's no need to rush here.
Which one?
I can write it down.
Okay, yeah,
Because it's your students working in a company and
Yeah.
you're working in university,
Yeah.
they can find.
Yeah, that's better.
So how does it work? What do you do
For this one now, but this is actually the technology itself. It's not the hardware. It's not our hardware. So that's actually a Swedish company.
I have something here. I want to.
So it's a very interesting company because these exist since for 17 years now. People,
Yeah, it's
So,
yeah,
it's okay.
Don't go
It's
through.
it's okay.
It's okay. Yeah, this is. You might use these images here, which are quite interesting.
that's
But
correct
it's
because I know some of the stuff,
Only
yeah, but not sure. I know for Indonesian stuff,
art,
but it's hard saying that. So it's
very
very more
interesting.
strict. So
You only want people
Okay.
also here, so you can have it as a single picture. Yeah, he's pretty famous. Yeah, but this is the mausoleum. The art shows, yeah, you see here. But this, you see older, younger people. Now I think it's from mausoleum. It's actually mausoleum. And it's totally serious. It's very serious. And high art.
some stairs, spin out.
You see here, it's also it's only open on Saturdays.
They are industry driven,
Okay.
but they have a lot of
Yeah, exactly. So you can find some for you suitable good image search. You find some
gets the
suitable picture.
maximum view, it's not
Okay.
Yeah, it's just, I mean, this it's extremely strong. It's things that are not shown.
Anotto. A-N-O-T-O.
It's a company in Lund, by the way.
Yeah.
We know.
Yeah, so, but they only give you the basic.
Yes.
This is
Something I try to think about it now, yes. So this, oh, I sent you the name right away.
I will see.
14 minutes.
But they want the notes in the PDF.
That's a system we built already that they proof. So that if you go to my website, you will find paper proof.
Then maybe.
But that's again a research prototype. But then basically you print your documents, you do all your annotations, corrections, whatever, and you integrate it with your open office.
Your work is
On this signature.
And that-
learning disorders,
Yeah,
because we usually
yeah. More people with learning disorders.
Sure.
Yeah.
Because it's better you write, because you can write it. It's better.
I really like.
But look into it, and we should maybe, if you can also write me down your email or send me an email, then we can also around here still. I don't know. We did that quite some time ago, but of course it was again not commercialized. But I could imagine because Microsoft now has a similar thing with patterns, so they might actually.
So you get this profile there.
I'm new here. So
Okay.
it's literally
This
using
code
the
for.
Yeah, then I have it also. That's an idea.
The thing is that I'm more interested at the moment as a user
Yeah.
on that,
Mhm.
and to also